I did my best to finish the other night's homework yesterday, so.
The optimization is the hard one.
I didn't even get to look at last night's homework.
All right, well, give me one.
What were the questions?
17 and 22. Let's look at 17. 17, they gave you the equation. You are designing a 1,000 cubic centimeter right circular cylindrical can. My goodness, what a mouthful. Okay, right circular cylindrical can. Like a tongue twister. Whose manufacturer, should say manufacturer, okay, will take waste into account. There is no waste in cutting the aluminum. This is what we were talking about yesterday, whenever we were talking about, this is exciting, right? Okay, that's okay. Because they'll give that to you on the exam. They'll say, given that the volume of a cylinder can be found by blah. Now, they won't give you, if it's something like the volume of a right circular cylindrical can, yes. Now, you don't have a formula sheet, but it'll be embedded in the problem with that. Yes. But the top and bottom of the radius R will be cut from squares that measure 2 R units on a side. The total amount of aluminum used up by the can will therefore be, so this is area. Remember, I need to decide what I'm optimizing. The ratio of H to R for the most economical cans was 2:1. No.
I had 4.
Okay, so well, because it tells you to look back at example 4. So, well, if you flip back to example 4, the only thing that's changed here is the area equation, right? And it says that, does it say the volume is 1,000? What did it say the volume was? Yeah, 1,000 cubic centimeters. So the volume of a yeah, that is pi r squared h. That's how you find the volume of a cylinder. Pi r squared h. That's how you find the volume. And it says that this particular one has a volume of 1,000. Okay. This is what we're going to optimize. Because it says we'll take waste into account, so I want the least amount of waste. So everything above, and listen, they do this a lot on the exam. They'll give you all this gobbledygook above it, like all that. You don't even need to know all that. That the radius R will be cut from squares that measure 2 R units on each side. Blah, 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 blah. They've already taken all that into account when they gave you this. Okay, so given this and given this, can you minimize the area? Find the minimum value. Do the extreme value theorem, or do your sign analysis and find the minimum. If I just gave you this equation, I said find the minimum. You need some more information because you've got 2 variables in there, right? I need to get it for just one variable, which is why they give you this information. So they'll give you another equation that will allow you to get the one you're trying to find the max or min of. It'll allow you to get it in one variable. Okay, so here h is the same thing as 1,000 over pi r squared.
Why?
Yeah, I just solved it for h because here's the thing. Before you find a max and a min, you can only have one variable in that equation. Okay? They gave me the red equation, the 8r squared plus 2 pi r h. And they told me that the cylinder had 1,000 cubic centimeters. But I know that this is the one I want to find the minimum of. But I can't find the minimum of this one because if I do the derivative, I've got an r and an h. Before I can do a derivative, I just need one variable. So I'll use what they gave me here, and I'll replace h with this, and then I can take the derivative.
Yeah, I know. It's like, why was 1,000 not there?
Well, I divided both sides by pi r squared, so 1,000 over pi r squared. Okay. Let me get my new, remember where we started, okay? Identify your equation that needs to be optimized so that you don't start going back and forth. That's what I would do. The very first thing is I would say, what am I trying to find the max or min of? That's your key equation, okay? The only thing the other one is used for is subbing in. Y'all okay? All right. So now I have area equals 8r squared plus 2 pi r, but instead of h, I'm going to replace it with this. 1,000 over pi r squared. I'm going to simplify it a little bit just because I know that I have to take the derivative next. And taking the derivative here would involve a product rule, and it'd be a little messy. It's just a little bit easier for me if I clean it up a little bit before I take the derivative. And since this is multiplied, the pi's are gone. One of the r's is gone. So I end up with 2,000 over r, or r to the negative 1. Is anybody confused? Y'all okay? See where everything's coming from? See what we did? All right. Now we're back to what we were doing in the beginning. Find the derivative. It's not hard now, right? That's what they'll do. They'll start out looking just gross, but they'll simplify down nicely for you. All right, derivative here. Okay, so if I do that, remember I'm setting equal to 0. Any ideas here what I might do? I'm with Noah, though, on putting it over 1. I'm not going to do it to cross multiply, though, because I can't cross multiply unless they're separated by an equal sign. But I could get them on both sides and then cross multiply. Like I could add that over there and then cross multiply if I wanted to. Well, I can't do that now. Yeah, I can't do that. Any other ideas? We'll do Noah's, and then I'll show you what I would have done. I moved it over. No, no, stop. I'm going to cross multiply. So I get 2,000 equals 16r cubed. Of course, if this was a calculator problem, and it is, I could have just put this in my calculator this way and found the zeros.
Wait, this is a calculator problem?
It is. I don't know. I like to make things more difficult. I'm still going to have to do the... Is it 5? Is it an... Now, what? You know how you're breathing right now? Stop. Stop. I'm just thinking, I'm saying this. I was saying that's what it's like when you tell somebody to stop coughing. Since COVID now, if you cough, oh my goodness.
What are we doing now?
We're going to find the minimum. We're going to find out if this is a minimum. Here is 5. I can't go below 0, right? But also 0 is an undefined point because it's in the denominator here. What's the biggest it could be? It couldn't be 1,000.
How did you know it's time? No.
Well, the radius can't be any less than 0 because then it would be negative. So we're looking for H and R. What? We found R, but we're looking for the radius one at the minimum. The most economical, which means the least area. So I'm looking for a minimum of area. All right, so let's just assume we don't even know this maximum because that would be kind of hard. But let's carry on. What is, huh? Well, we don't want a max. We don't, I don't know. Okay, so between 0 and 5 is the derivative of area. Now remember, this is the derivative of area. Again, you have your calculator. Let it work for you. Between 0 and 5, in other words, if I plugged in 1 right here, positive or negative? Beyond 5, if I plug in, say, 6, should be positive because 16 times 6 is pretty big, and then 2,000 divided by 36. So, here is my minimum value, right? So when R is 5, that's a minimum. Well, now my question is, when R is 5, what is H? 1,000, what was it? That's what H is. If I need to find H, that's what it is. So I got 1,000 over, now simplify it, 40. So the ratio of the radius to the height of the most economical can.
5 to 40 over 5.
No, I could reduce that by dividing both of them by 5. Let me take it one step further.
Like if someone was like, this can you're measuring needs to be with a ratio of 5 to 45. How do you do
that? Say that again? I didn't plug in one, I just reduced the, remember a ratio is nothing more than a fraction. So you can, as long as you can divide both of them by something, I just reduced the ratio. You can do either one. I was going to say, that would be what, 7th or 8th grade?
Well, look, she put me to sleep.
The optimal radius is 5, or actually the optimal radius would be 1, the optimal height would be 8 over pi. What would the optimal area be?
You just plug it back in. You just plug it in. What do they want to know?
So it's 8r squared plus, I know, I took this a little bit further. Yeah, you did. It said the radius, what's the ratio of h to r? I got it backwards. So, but I just wanted you to understand, what if the question had not been what's the ratio of h to r, but what's the optimal area?
So then we would need to find both and then plug them.
Correct. Correct. Yes.
Or if you wanted to.
Not the derivative equation, but the area equation.
If you wanted to, you could just find r and then plug in that h.
You could. You're absolutely right. Good job, Dylan.
I might have solved it for the area. Wait, so if I didn't write the simplified version, I'll still get it right. Like 5, 4, 1, 8.
Yeah. No. Well,
I mean, it's not hard to simplify.
If you didn't simplify the ratio, I would say no, because it's still fine. Yeah, I think that's fine. All right, and then you said 22? 22 is a good one.
What were the questions? Any questions?
I don't remember. It's on there.
Anybody know the numbers?
Yeah. 10, 12, 13, 14, 17, 18.
Wait, 10?
10 doesn't have an A.
10, 12, and 13.
Oh, that's what that means.
Okay, well, sure.
Oh, I like this. Y'all make me laugh early in the morning. Okay, 22, maximum. Oh, goodness. Oh, it is a short one. Okay, well, let's remember what I said. Draw a picture.
Let me tell you one thing, though, Miss Vicky. Those solutions.
You don't have a circle on there, a sphere on there.
Those solutions, like, do not help.
No, they don't.
I'm sorry.
They're nothing like the way we're doing it.
They like.
They skip so many
Yeah,
steps.
They do skip a lot.
Like during the
Well, they used to not.
They would skip the entire sign chart and
Or they would do their sign charts differently.
Yeah. I'm sorry.
I threw a couple pictures on this.
They make it confusing.
No, why?
If x is greater than this, then
I should,
slope is
but no.
greater than this.
All right. Dylan says this is a short problem, so it should be easy. So here we go. Find the dimensions of a right circular cylinder of maximum volume. So right now, that already tells me what I don't even know what that equation is, but I know the volume of a right, what did it say?
A right
Circular cylinder. That is what I'm optimizing. Okay? Yeah. Yes, that's a cylinder. Think like a vegetable can.
I guess from the.
Well, maybe there's a right angle with the base.
It's, yeah.
Yeah.
Look it
All
up.
right.
Okay.
So what's the formula?
There's not, the right is indicating the, right angle.
All right. What does this mean?
Yeah.
That can be
Okay.
inscribed.
I said look up the left one.
A radius 10
Okay. I was up way too late last night. Yeah. Cake season. Okay, what? Yes, yes. So inscribed just means that the edges touch it. Okay, so I know what I'm optimizing. I'm optimizing because I want to know the maximum volume of the cylinder. It's inscribed in a sphere of radius 10. What's the maximum volume? Okay, so let's look at the sphere. What's it say, Jesse? Slant. It means slant. Because think about your oblique asymptotes. It means slant asymptotes.
Never heard of that.
So right is just right.
Maybe I got some Doritos.
Okay. There's my sphere. Pretend like it's three-dimensional. And inside this ball.
Oh wait, I thought it was like a.
It's all wrong.
Or is it at the bottom?
Oh, never mind.
Oh, yeah. Oh, well, they're saying they could throw the cylinder inside of the circle.
Right.
Wait, why?
Right. No, Mom.
Right? Are y'all with me?
What is this?
It's a can inside a ball.
Is it inside the
Because it says it's inscribed in a sphere. And it says that the radius of the sphere is 10. Now, if the radius is 10,
Yeah.
the diameter is 20, you're exactly right. And how does that help us here? Well, that's going to help us because the height of our cylinder is going to be 20 because it's inscribed in the sphere. Okay, so that's what tells. That's why it helps to draw a picture. Remember, a sphere is just a ball. It told me in the problem that the radius of the sphere was 10. Yes.
So the height is double the diameter. No, wait, no. The height is the diameter.
The height of the sphere inscribed in the height of the cylinder inscribed in the sphere is the diameter of the sphere.
Okay.
And the diameter of the sphere is twice the radius.
Sure.
No. Okay.
That's
I know what that is.
What if I have this? I know how to picture a right circular cylinder inside. We know some.
All right. Miss Nikki, what's the volume formula again?
You know what? No. The height is not 20. If this is inscribed,
And that means that it's going to be.
the radius is 10 of the, right?
Maybe it should that other than not be 10 because that should be the hypotenuse.
What?
The length of the. Yeah, because it's on the opposite.
But it could be equilateral.
Well, because if you think about, if I've got I wish I had a, the top of the can's not going to hit the top of the circle, right? Because it's flat, but the circle's rounded. So if it's inscribed, the corners of the cylinder are going to hit the circle. So from the center to that corner would be the radius of the sphere. That would be 10. And because it's a right cylinder, if I come straight up from the middle at a 90-degree angle here, right?
Well, how do we know what the difference is?
Why are you doing 100 minus 25? What are you doing? Well, but it's a 45, 45, 90 triangle. You don't know one side. How do you get a 30, 60, 90?
How do you know 45, 45?
Yeah, I know that.
Tell me that.
So it looks like mine. I'm just kidding.
Is it hairline looks like?
Well, you don't want to.
Like an L for
Yeah, exactly.
What's the volume? What's the volume of a right circular cylinder? Somebody's.
R squared H. Alright, so we found
Let's
R.
label everything.
We can just find H. Let's do implicit differentiation for H.
No, wait. We've got R of the sphere. We don't have R of the cylinder.
Well, it's inside the sphere.
Yeah, but okay, so if I've got this cylinder,
It's not a radius first.
sure there is. There it is.
Alright. I didn't know something about that.
And that's the height. Yes, it is.
Well, that's not even the height of the sphere then. That's like an inch or two taken off. Because, you know, the top of the sphere. So basically they're saying all we need to know is that it's the radius of the sphere is 10 centimeters. That's all it is. So what can we do with that?
Well, I'm thinking right now.
That looks like a 30-degree right there.
If I had 1 week math subject in all the math subjects in the world, I hated geometry.
I hate geometry too. For me, it was. I took it for a full year.
And when I first started teaching, a 216 meter squared rectangular pea patch, draw a picture. Yep. Make sure you put the peas in there.
Alright, let me make sure.
Did you hear what I said? Make sure you put the peas in there. A rectangular pea patch is to be enclosed by a fence and divided into 2 equal parts by another fence parallel to one of the sides. It doesn't say. So it doesn't matter. All right, so it says parallel. It could be anywhere. Yeah. So you could cut it there. Yeah, it doesn't specify. Well, it didn't. Oh, 2 equal parts. Okay. Y'all, my goodness. If I put a couple more peas here, it'll be the same. Okay. What dimensions for the outer rectangle will require the smallest total length of fence? Okay, so there's my optimization, right? What dimensions for the outer rectangle will require the smallest? Now, we're talking about fence, so we're talking about perimeter, right? Are y'all okay there? This is X. Okay, that's fine. If we let this be X, because it's rectangular, this be Y, and this be Y.
Wait, this question was in the other night somewhere. It was 1 through 11.
Now, this is fencing also, right?
It was 1 through 11 odd.
What you do all? And how much fence will be needed? So, that's right. I've got 3 X's plus 2 Y's. That's my perimeter, right? And that's what I'm trying to optimize. Okay, so it does. It wants, but it says that you have to draw that parallel one in there. And you have to include that in your amount of fencing. Okay? And what it tells me is, because it wants to know what would the dimensions of the outside rectangle be. That's okay. You'd have the X's, it'd be 3Y plus 2X equals P. It's okay. It's okay. All right, so it says a 216 meters squared. What does that mean? What is square meters?
It only wants to know. It only wants to know.
Is that it's area?
It only wants to know the outer rectangle, not the.
But I have to take that middle one into account because it says that it's to be enclosed by a fence divided into 2 equal parts by another fence parallel to one of the sides. What dimensions for the outer, well, I'm trying to require the smallest total length of fence. So total length of fence would be all the way around plus the middle. Because all of this is fence. Fence, 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 fence. But I also have this fence here.
That's the inner rectangle.
Yeah, but what I'm going to do, okay, so I shouldn't call this perimeter, I should call this fence.
Yes.
Because that's the amount of fence I need, right? And that's what I'm trying to minimize. I want all this to happen, but I want the least amount of fence possible. Okay? All right. Now, it told me, remember, when you've got 2 variables in here, it's got to, what, do you feel okay? You sure? You look like you don't feel well. Okay. It's got to give us something else so that we can get it in just one variable. And it does. They give you, how do you know it's the area? That's what I was getting. It's meter squared, right? So if area, and that's the big rectangle, right? Are y'all okay? So x times y equals what? What is it? 216. Now I can solve for y to plug back in here so that I can have just, remember, this is what I'm optimizing. Whatever I'm optimizing is what I'm taking the derivative of. Yes. Because it said in the very beginning, a 216 square meter rectangular p-patch. So when you see this, this clues me in that it's area. Stop. Okay, so I'm going to solve this for y and say y is the same thing as 216 over x. Do we agree or disagree? Go back to the equation that we are optimizing, the equation that we are looking for the minimum value of, right? Because I want to spend the least amount of money I can on fencing. So I have 3x plus 2 times 16 over x. This is my amount of fencing, so I will call it f. 3x plus 432. Well, this looks just like the other one we did a minute ago. But I don't have to do any of that just yet. Well, y'all, you're forgetting something. I gotta find the derivative first. Because I'm trying to find a max or min. And maxes or mins happen when derivatives are 0. You could, but that wouldn't be using calculus, dear Dylan. I'm glad you think that the calculus makes it easier. I'm glad to hear that. 3, you think it's just 3 is the derivative? Oh, okay. Okay. Lizzo. Do we agree or disagree?
I'm gonna send the derivative.
Well, I thought it was
3x.
I thought it was
I almost said the derivative.
I would multiply everything by x squared.
You really would.
You know what I would do? Because this is the same thing, I would just flip both sides. So I would just multiply by 432. Yeah. Again, this is a calculator problem that we're taking way longer on it than what we have
Well, you
to.
can square root now. Let's square it out.
Well,
Not
this
very
probably
much.
goes in an even number of times, does it? Let's test it and make sure that that is a minimum. First world problems.
Yeah, I only have the 0.03.
All right, let's plug in 1.
0.05.
Let's plug in 1 up to date.
Okay, plug in 1. What am I plugging it into, Dylan? The derivative. I keep stressing that because y'all keep getting confused on what you plug in when.
Oh, no.
I'm plugging into the derivative to find the sign of the derivative, right? It's negative. How about past 12? She's assuming because it asked us to find a minimum, and she's assuming that the
No,
sign.
it's way negative, Miss McGee. Way negative.
Way negative. What's way negative?
Plug in past 12. How is it possible?
Go to your. You're dividing 432 by a huge number.
Yeah. And you're subtracting that
So
number
if you do like 432 over.
subtracting that huge number from 30. 432 over 16.
How many?
It's like 20. Oh wait, yeah, minus half.
So what's 3 minus 2.5? Pasta.
Well, if you like, if you plug that exactly at 0.4437.
I don't know.
All right, so we got a minimum.
Okay.
Of 12 and stuff like that.
What does that tell me? It did not answer the question. My minimum value is 12, but the question said, what dimensions for the outer rectangle will be required for the smallest total length
Well,
of
that's gonna be your
fence?
width.
So now you have plug 12 in.
Okay, so that'll tell me the amount of fence. That'll answer the second part of the question. But the first part of the question says, what are the dimensions?
We have what? Wait.
What are the dimensions of the outside? X, X, Y, Y. I just need to know it. X is 12, so I know it's 12 by what? Right.
Well, we already know the area.
And we know Y is, what was it, 216 over X? Isn't that what we got?
It's not hard.
Well, you'll plug it in here to find Y.
What's 216 done up for?
I don't know. You tell me.
I don't know.
18. So the outer perimeter is 18. And then it asked me, not just what is the outer perimeter, but also how much total fencing will be needed.
They tell you the area.
Not area, how much fencing, because remember, I came in here and I have another fence here. So it's going to be 18, 18, 12, 12, 12. So I need 72 meters of fencing. So this is meters, this is 12 meters by 18. Ask me for both the dimensions at the end as well as the total optimization question. So you asked for a step-by-step. So this is what Josie's asking. When you optimize, the very first thing you need to do is identify the optimization equation. That's always the first thing I do. Now, with that said, I guess I should say prior to the problem starting, always draw a picture if you can. I know it sounds silly, but it always helps. All right, so identify the optimization equation. I'm gonna call this OE. get the optimization equation in just one variable. So when you do this, this is where you have to look for some other equation that will define those variables for you. So look. So for example, did they give you the Did they give you specific area or volume or something of that sort? That's where your equation is normally coming from. Yeah, I can't. All right.
I don't care.
Find the derivative of the optimal equation. A little hard to cheat in this class.
Well, I'll tell you how I choose. I did. And I changed mine. I knew it was true.
I'm gonna make this just one step. Find the max or the mins, depending on what you're looking for in the question. So this is where the derivative of the optimization equals 0. And then, yeah, I feel like it's downhill. I feel like once you identify your equations and you get it written in just one equation, one variable, it's downhill from there because it's what we've already been doing. Sign analysis, sign chart. And then this is the point where you go back and answer the question.
Is it always 0 and something else?
No.
Optimization equation.
Yeah.
So, like, how do you know which number to use for sign chart? That's why I messed up on the quiz, I think.
That's where your derivative of your optimization equation equals 0. Once you find that optimization equation and you get it written in just one variable, then you take the derivative.
They don't tell you if you look for a little or a back.
Yes, they will say, or it might say something like, what's the least amount of material you could use, or the least amount of surface area, right? But you'll see least amount or most amount. That's what, right. Once you get to this point, it's what we've been doing.
All right, let's do 12. Let's do 12. No, let's do 12.
Let me show you linearization and then I'll come back to 12. But yeah. You're going to look at linearization and go, oh my gosh. In fact, the only reason I am taking time to talk about it is because if you see the word linearization, I don't want you to wig out about it and go, what? We haven't done that. Because you have done that. So the wording of linearization they even come up with a whole separate typical calculus, this wordy, lengthy definition / way to plug it into a formula, another formula. I hate memorizing formulas whenever you already know how to do it. It's just rewriting it a different way. You understand what I'm saying? So I don't like teaching it that way. So all linearization is it's the equation of the tan line at a point. And then we use that equation to estimate a value. I bet it's free. It is. That's exactly what you're doing. That is exactly what you're doing. You're getting a linear approximation. That's all you're doing.
Oh, but it just like the dots all over and then you have a line.
Right. So the linearization at a point is just the tan line at the point. That's all it is. So let me do an example with you and show you the way it's worded. So this one says, let me get one from that. We're actually going to skip over Newton's method. I decided I've been going back and forth, and I decided to. It's used to estimate zeros of a function, but you use your calculator anyway to do it. Well, if I'm using my calculator, if it's a calculator problem and I need to estimate a zero, what I'm probably going to do is graph it and do second trace, calculate zero. Okay, let's say I don't know what that means. Okay.
Yeah, I know.
Now, this guy should not even be in trial. Don't just be in trials and be set that up. Yeah. Well, they pointed a gun at him.
Okay, let's do this one and then y'all can talk about y'all's politically heated opinions on.
Someone points a gun at me, I'm going to shoot them.
This says to find the linearization at x equals 0. And then use it to approximate the square root of 1.02 without a calculator. So let's talk about what that means. We're going to do. All right, so exactly. So the first thing the linearization at x equals 0 just means tan line. Okay, so you're exactly right. Let's find the derivative. The derivative of f.
There is no chain rule.
Yeah. You didn't mean to hold up a second. Okay. Okay, so 1/2, 1 plus x, negative 1/2. Chain rule, but it's just 1, like you said. Is that all it is? That's the derivative. Don't forget, don't set it equal to 0. We plug in 0 because it's at x equals 0. They said to find the linearization of f of x at x equals 0. In other words, the tan line at x equals 0. That's it. So remember, to write the equation of a line, we need a point and a slope. The slope, right? That's the slope. What do I need to write the equation of a line? I'm missing a point. Yeah. I've got x equals 0, so what is y? So this time it's f of 0, plug it in, square root of 1 plus 0. Now write the equation of the line, but we're going to solve it for y when we do this. Y minus 1 equals It's slope times
X
x minus 0. Because this point is 0, 1.
Oh, so
You don't have to, that's not my fault.
wait, so
Well,
you solve
for
that
linearization, we are. We want to solve for one.
negative
Why do I want to do that?
Say that again, Noah.
So I just looked right here. It's 1/2 times 1/2.
Well, 1 to the negative 1/2 is just 1. If that were not 1, remember the negative 1/2 would be 1 over the square root of 1. We have done this before. That's why I said we've done it before. We're just giving it a new name, linearization. Yep. Yeah. It's the 10. Okay. This is the linearization at 0. That is the linearization at 0, right here. The second part of the question says, use your linearization to approximate the square root of 1.02 without a calculator. Okay, so I don't have a calculator. Look at the original equation. What was the original equation? F of x equals. So what I'm going to do is, if f of x is the square root of 1 plus x, and I'm trying to find this, what am I talking about x being in that equation?
So set 1 plus x
X
equals
is
1.02.
Yeah,
Use your linearization equation to plug in to estimate that, because I don't know what the square root of 1.02 is, but no, this would be a non-calculator. So here it would be 1/2 times 0.02 plus 1. This is just an example in the book. Yes, so what I'm going to do, we use the linearization equation. Linearization. This is exactly what it says. Use linearization equation to estimate a value. And so when it says that, all you're going to do, look at the original equation. Now, we've already done all that, but if it says to, after we have our linearization, look at the original equation, find x, and plug in to the linearization equation. The reason we do it is, and we keep calling it linearization equation, but really it's just the equation of the tan line. That's all it is. We've made that function linear at a point. And so all we're doing is we're going to plug that into the linearization, because it's easier for me if I don't have a calculator to evaluate a linear function than a radical function without a calculator.
So the linearization equation is
Yes.
just the same thing as the point slope version of the line.
Yes, yes. Yeah, no, go ahead.
There's 2 points. 2 things, check marks, correct?
Yeah.
The tan line and the.
Yeah.
Is that it?
Yeah, that's all linearization is.
Probably.
No, that's all. That's as far as we're going with them. Mm-hmm. Yep. It's estimating if you don't have a calculator. That's what Newton's method does too. Is it's another way to estimate values using a different method. But I have seen linearization, the word linearization, pop up on the exam before, so I wanted to make sure you understood. If it says linearization, that means equation of the tan line. It's making the function linear at a point, is all it's doing. I'm going to give you a couple of those, but I'm going to give you some more optimizing problems too. Let me tell you about the linearization in the book. So whichever ones I give you, and it could get a little bit more difficult as far as what the equation itself is. This was a pretty easy equation to find the derivative of. It was a radical, but still. It's convoluted. It says find the linearization L of x of f of x at x equals a. How accurate, blah, blah, blah. You're just writing the equation of the tan line. The a is the x. So in other words, number 1 says f of x. Yeah. You know what I mean?
So,
You might have one that has linearization. Is that what you're asking?
no, I was gonna say, are we gonna do memorize the, you know what I mean?
Let me look at it and
So like
see.
1 over x.
Let me
plus
look
x
at it and
squared.
see. We'll probably focus more on those when we hit the review section next semester. So I'll say if you need them, I'll give you the inverse derivatives.
Because I thought like the derivatives.
We'll start really drilling those a little. As long as you know how to use them right now, we'll really start drilling those second semester. Probably do some Kahoots and some little things just to try to help us get them. This just means find the equation of the tan line at x equals 2. That's all they're asking you. Okay? So just get past the wordiness of it, which is so much of calculus anyway. Get past the wordiness. What? I don't know yet. I don't know because I want to see. Let me see.
So A would equal X,
Right. I know y'all. I fly by the seat of my pants and looking for
right? You just put down 2 and 3. No, those are.
What's a poogle?
This is stupid thing you want to do.
I might want to do that in my class.
No, you don't.
No, you don't.
Yeah,
You can grade it, anything.
A poogle?
no, it's literally just like a document.
Spell it. They make math ones?
I'll only do like the first like 2 pages and then
I guess I'll give you your homework first, then we'll set one up at least.
I know he doesn't go on it and like scroll through it and see if he's got it.
There's puzzles on that.
Is there?
Oh god.
What'd you get?
I got not like it or like
I don't have the answer.
Like this, and
Mm-hmm.
I use the derivative,
Mm-hmm.
and I just put 2 in for x. Not 10.
Mm-hmm.
Two, 7. How's that wrong?
It's not. I didn't say it was wrong.
I thought you said that.
No, I said I don't have the answer in front of me. Let's do numbers. What did y'all do before? Y'all did 1 through 11 odd. You did odd. So let's do number 2. Not really like 4. Ooh, let's do 6 is good. Did we not do 8? Is that not the one we just did? That's the pea patch. No, that's 10. That's 10. That's 10. Never mind. Y'all didn't have any problems with 12? Oh, man.
wait, so what happened if I okay.
I don't like 8. Yeah.
Was on he was on like a movie set and he had like a talk. Basically he was just in one face. But it was like
18 super. I think you can do 18. They just already drew the picture for you. I'm giving you one more challenge.
Well, Alice Osborne was doing it wrong, and it was common. Basically, they were having riots in Wisconsin.